Hello students, we are discussing on pavement material and characterization. Previously we have discussed on the road aggregate, wherein we have discussed about the desirable properties of road aggregate. We have discussed the gradation of road aggregate, the physical properties of road aggregates. The next concept that we have to learn, we have to go through, that is resilient modulus of road aggregate. What it says. Previously, we have learned this concept in subgrade soil, that is resilient modulus for subgrade soil, wherein we have learned about its elastic properties. Same way, for the road aggregate, we have to discuss almost same for the road aggregate. So now, what change in road aggregate? This concept is the resilient modulus has been proposed as a means of characterizing the elastic properties of pavement material. It is expressed as the ratio of deviator stress applied to the pavement layer and the resilient axial deformation, that we can say the strain recovered after release of the deviator stress. Same way, for subgrade soil we have made a ratio mr is equal to sigma upon epsilon. Same way here you can see that the ratio of deviator stress, that is sigma, and the resilient axial deformation, that deformation we can say it's like an epsilon. So there is an assumption, that assumption are made that the pavement material are designed for loading in the elastic range, and that the resilient modulus is the only parameter that needed to design the thickness of the pavement. So if you are designing any pavement that is flexible pavement or else rigid pavement, so if you want to design the thickness of that pavement, for that you must need this parameter, that is resilient modulus. The resilient modulus test provides a relationship between deformation and stresses in pavement materials that includes aggregate bases and subgrade soils. For the subgrade soil we have already discussed this topic, and this is for the road aggregate basis that subjected to the moving vehicular wheels. Hence it is not necessary a fixed value, but it varies according to the applied stresses of moving vehicles and the resulting stress level in the pavement layer. Here simply you can see that it is not possible to have this equal stresses during whole day on the pavement surface. We have different vehicles. For the heavy moving vehicles, the stress would be more. For the low weight vehicles, that stress would be slightly low. So here the stress is not fixed, it varies with the moving vehicles and the resulting stress level in the pavement layers. So the elastic resilient modulus. Now resilient modulus and elastic modulus both are almost same, as resilient modulus is giving the elastic property of that particular aggregate. So this modulus value of this granular layer is musically dependent on the resilient modulus of the foundation, that is kind of the supporting layer to the granular layer, and the thickness of that particular granular layer. These two things matter on the resilient modulus. Now below equation is giving the value of that modulus resilient. The equation is the modulus of resilient for the granular layer, that is of the product of 0.2 into H into 0.44 into the resilient modulus of that supporting layer, wherein as we discussed above that it depends on the resilient modulus of supporting foundation, that is MR support, and H, that is the thickness of that particular layer. If you have decided that what resilient value you want, then after you can design the thickness of that particular layer, or else if you have that thickness, you can identify or you can measure the resilient modulus value of that particular layer. Here the unit of this modulus of resilience, that will be in megapascal, and the thickness would be in millimeter. As here you can see that modulus of granular material is proportional to the modulus of supporting layer and the thickness. So as the supporting modulus will be high, you will get the value of MR for that granular. So if the supporting layers modulus resilient will be high, you will get the granular modulus resilient high. So the elastic property of that layer would be high. Also, as discussed before, that for this particular topic, the main motto to find this resilient modulus is for the designing the thickness of particular layer. Okay, so here the thickness of that layer is also matter. So when the pavement has the combination of granular base and granular subbase, the modulus of the single granular layer may be estimated. At that moment, the whole base and subbase both are considered as a single layer, and that may be estimated using the above mentioned equation, that taking the MR granular, that is as the modulus of the combined granular layer, and the MR support, that is the resilient modulus of support, as the effective modulus of the subgrade. So this is what about the single layer. Then if that particular layer is that granular base that is placed on cement treated subbase layer, at that moment the resilient modulus may be taken as 300 megapascal to the 350 megapascal for the natural gravel and the crushed rock respectively. In such type of cases, the two-layer system of the granular subbase of selected thickness and the subgrade with the effective modulus is converted into the equivalent granular subbase of infinite thickness, whose effective modulus is to be determined by the multiple trials, that is a kind of trial and error methods, and you can define or you can find out the effective modulus value of that particular layer. So this is all about the resilient modulus of road aggregate as well as the granular layer. Now next we will start the next material which we are using for the pavement construction, and that material is nothing but the bituminous, which is a kind of binder material which work as a binder material in the pavement. Basically bituminous material is classified into main two parts. The first is bitumen, or we can say asphalt, and the next is tar. The bituminous have classified in two categories, that is native asphalt and the petroleum asphalt. And the petroleum asphalt have already two types, that is cutbacks, emulsion, and also there is a modified bitumen. Okay, this is also a classification of the bitumen. So let's discuss about this all bituminous material in detail. So bitumen. Bitumen is a petroleum product obtained by the distillation of petroleum crude in the refinery. It is a hydrocarbon material of either natural or cyanogenous origin found in gaseous, liquid, semi-solid or a solid form, and it is completely soluble in carbon disulfide and in the carbon tetrachloride. There are a few properties of bitumen, that is, it is black or a brownish black in color. It possesses adhesive properties when softened by the heat. It melts and it gives distinctive odor when heated. You might sometimes feel this distinct odor when you passing through the newly constructing road, bituminous road. At that moment you might feel this distinctive odor if it gets heated. The bitumen gets heated. It is also soluble in carbon disulfide. The main use of bitumen is it is used for constructing different bituminous road pavements, and also it is used as a stabilizer for constructing stabilized earth roads. The next bituminous material, that is asphalt. When the bitumen contains some inert material, or we can say minerals, then it is sometimes called as a asphalt. So it is a byproduct of bitumen, we can say. It is solid or semi-solid but sticky product which is formed by partial evaluation or distillation of certain petroleum oils. It possesses binding properties. Asphalts are soluble in varying degree in carbon disulfide. Asphalt may be found as a natural deposit or the prepared by distillation of crude petroleum in the refinery process. When found by natural deposit, the asphalt is called the natural asphalt, and when it produced by distillation of crude petroleum, at that moment this asphalt is known as the petroleum asphalt. If it found naturally, it will be the natural asphalt. If it will be produced by the distillation, that will comes under the petroleum asphalt. The natural asphalt may be either lake asphalt or the rock asphalt. So there is also a bifurcation. So now what lake asphalt contains? The lake asphalt contains 40 to 70% of pure bitumen, and it is refined by boiling in the tank, when the rock asphalt contains 10 to 15% of the pure bitumen. So this is all about the asphalt, bitumen and asphalt. There is very thin line between this bitumen and the asphalt. The next bituminous material, that is tar. Tar is the viscous liquid which is obtained by destructive distillation of natural organic materials like coal or wood in the absence of air. Based on the material from which the tar is derived, it is referred to as a wood tar or the coal tar. Coal tar is superior and is more widely used for the road work or road construction. There are 5 different grades of road tar, which is denoted as a RT, the RT1 grade, RT2, 3, 4, 5, and these 5 types of grades are there for the road tars, which is based on their viscosity and the other properties. Wherein RT1, that is road tar 1, has the lowest viscosity, and it is used for surface painting under the exceptionally cold weather condition. wherein RT5 is used for grouting purpose, which has the highest viscosity. So the grouting is like if there is a damage on the road and you have to repair it, or you want to maintain that road very smooth. At that moment you have to fill up that crack, and to fill up that crack you need the viscous fluid. So for that RT5 is useful to maintain or to resurface that road. So this is what about the tar. Now let us discuss the difference between asphalt and tar. So let's start the comparison. First of all, let me tell you asphalt. Asphalt is obtained by fractional distillation of crude petroleum, wherein tar is obtained by destructive distillation of organic matter, that is such as coal, oil, or wood, etc. Wherein in asphalt that distillation of crude petroleum. If we talk about the color, then asphalt is black or brownish black in the color, while in tar is purely black in color. The asphalt is in solid or semi-solid state, wherein tar is in completely viscous state. Asphalt is less adhesive, wherein tar is more adhesive than asphalt. The asphalt is more durable as well as the weather resistant, wherein tar is less durable and also less resistance to the weathering condition. Asphalt get melt when it gets heated, wherein tar becomes more fluid when it gets heated. The setting time of asphalt is less compared to the tar, wherein if talk about the its hardness or harden property, then asphalt gets very slow hard, and tar gets quickly hardened. Asphalt is costly, wherein tar is very cheap. Where tar is insoluble, while in asphalt we have seen that it is soluble in carbon disulfide and the carbon tetrachloride. So these are the we can say comparison between asphalt and tar, which maybe comes into the MCQs. So be prepared for it. So this is all about the comparison of asphalt and tar. Next we will see the emulsion, the modified bitumens, and it's a different taste. So I hope you get to know about, get complete understanding about bitumen, asphalt and tar. These three are the different bituminous material which frequently asked as a short note also in GTU. So it is very important, three topics for you, three materials for you. All the best. Thank you.